So in this video, we are going to look at how we can calculate density from a graph. So quick reminder, density is mass divided by volume. So if you're given those two numbers, mass and volume, it's very easy to calculate density. All you're going to do is mass divided by volume. However, when you're given a graph, we have to work a little bit harder to get our mass and volume numbers. So we're going to use this graph off to the right of the slide as our example because it has lots of substances on it. So there's a couple things I want to point out on this graph. First of all, our y-axis is our mass, our x-axis is our volume, and that's how a density graph will always be. We'll always have mass on our y and volume on our x. So if we substitute y and x into our formula, it's really y divided by x. If we think back to our math classes and what we know about a graph of a line, y divided by x could be the same as rise divided by run, which is our slope. So really, when we're calculating the density of a substance from its graph, we're really just calculating the slope of the line. So we can make this simpler because all density graphs should start at 0, 0. So instead of having to find two coordinates and subtract the y and then subtract the x and then divide, we can just assume that one of those points is 0, 0. So we really just need one y value and one x value. So I'm going to go ahead and erase this part, and we're going to work through just a couple of examples. Okay, our first example that we're going to do is gasoline. So gasoline is our red line, so it's this one right here. Okay, and for gasoline, we're going to look for a y value and an x value, because remember, we're going to use 0, 0 as our first one, so we really just need one other point. And I can pick any point along this line. My graph isn't super detailed, so we're going to have to do a little bit of estimation. So I'm going to go with this point right here because it looks like that line is right at halfway. Oops, that's not a very straight line. Looks like it's about halfway between 50 and 60, and then it drops right down at 80. So my y value, I'm going to say, is 55 grams, and my x value is 80 milliliters. Again, this is some estimation involved because my graph isn't super precise, but I'm going to type into my calculator 50 divided by 80, which gets me a density of 0.69 grams per milliliter. So again, just calculating the slope. Okay, let's look at another example. So my next example that I'm going to do is vegetable oil. So vegetable oil is this kind of goldish line up here. Okay, so I have veggie oil, and I'm going to do the same thing. I'm going to assume 0, 0 as one of my coordinates, so I'm just going to find one more point, and actually it's going to be kind of similar to the one that I used for gasoline. I'm going to use this point right here because I think, again, it's pretty much right in between 50 and 60, so I'm going to say that it has a mass of 55 grams. But this time when I drop down and look at my x value, it's at 60 milliliters. So when I type that in my calculator, 55 divided by 60, I get a density of 0.92 grams per milliliter. So I want to take a second and make sure that this makes sense. So if I look at my graph, so I have my two lines, I have vegetable oil and I have gasoline. The line for vegetable oil is steeper, which means that it's going to have a greater slope, which it does when I look at my number. The number calculated for the slope of vegetable oil is higher than the number calculated for the slope of gasoline. And that also makes sense because we know that if we're just visually looking at it, the steeper the line, the denser the substance. So the greater density has the steeper line. So we could go through and calculate this for any of these substances on this list. It'd be the exact same process. You're just going to find an X value and a Y value, and then you're going to divide Y divided by X, and that is your density.